So I'd like to welcome officially Mr. Ashraf Takla with Mixel.
Well, thank you, Sean. Um, so today I'm going to be talking about MIPI and the Mixel MIPI IP portfolio. So to make the presentation relevant, it would be great to find out who has ever heard of MIPI before or have some familiarity with MIPI. Okay, so most people don't know what MIPI is, so that hopefully will make it even more informative. So MIPI is an alliance of companies that was formed in 2003, so many years ago. Its focus originally was mobile platform, so the focus has been on developing standards that address the mobile platform. It has hundreds of member companies. Some of them are contributors, some are adopters. And the MIPI Alliance over the years have developed tens of standards to support the mobile platform. In the last maybe 6 years, because of the great success that MIPI has had within the mobile platform, a lot of adoption for cameras and displays, which are of course used heavily in the mobile platform. It started to be used outside mobile, and that is where a lot of the growth is coming from now. So this is just to familiarize you with the different market segments and the applications. So of course the biggest market segment is mobile. That's where it started. That's where most of the adoption is still today. A lot of upcoming application that is gaining a lot of traction, such as IoT, automotive, virtual reality, augmented reality, medical is starting to see some. In terms of the applications, many different applications, but the key applications, and that's what Mixel focus on, is interface with camera, display, and chip-to-chip communication. So Mixel is focused on the physical layer, the SerDes between the different components that support MIPI. So this is an example of a mobile system diagram. It shows all the different components that are typically used in a mobile platform. So of course, as you can see in the center, you have an application processor. You have cellular modem. You have Bluetooth, many different components. Of course, key here is the display in the upper left-hand corner and the camera next to it. So obviously, each mobile platform now has one or more of those. Then you also have, of course, quite a few chip-to-chip communication kind of interfaces. Mixel focus, as I said, on the physical layer for high-speed data transmission. So that is widely used for the CSI, which is the camera serial interface, camera application, DSI, which is the display serial interface for display application, and then the chip-to-chip communication. Through the years, there has been multiple PHY standards, specification introduced by the MIPI Alliance. Currently, there are 3. The first one was DPHY, and that has the widest adoption in the industry. There is also a CPHY and an MPHY. So in this particular diagram, you see the CPHY and DPHY mostly used for display and camera. The MPHY is more used for chip-to-chip communication. This is a similar diagram, system diagram, but for automotive application. So the modern cars now, of course, has many cameras and many displays. Automotive electronics is a great growth area for semiconductors in general, and of course, MIPI is riding on that wave. So a lot of the penetration in the automotive industry with camera is very high with MIPI. Display is a second. You can see a typical car nowadays has between 4 and 8 cameras, and that is only growing to support the ADS, and which is autonomous driving system, and ADAS, which is advanced assisted driving systems. So this is an area where MIPI is showing a lot of adoption, and of course this is only a few pieces of the many things that the MIPI specification is used in the automotive applications. Now let me tell you a little bit about Mixel and MIPI. So Mixel has been a member of the MIPI Alliance since 2006. We have been very active, focused on MIPI applications, specifically the physical layer. We are the first to silicon prove the DPHY, CPHY, and MPHY. So we support all the MIPIs. We also have a platform FPGA support so that our controllers and the PHY can also be integrated with a FPGA to support the customer's requirement. We believe we have a differentiated solution in terms of power and area features, different configurations. We believe we have the largest share of the market. We have over 85 MIPI licensees. We have wide coverage of the different foundries and nodes. And we also have developed a alliance of companies that support our MIPI customers from the different requirements, such, of course, the PHY, the controller, the VIP, the testing, test equipment manufacturer, labs that support MIPI, systems, and that enable the customer to get all they need to go to production very quickly. I'll tell you a little bit about the different PHYs. So the widest adopted PHY is the first PHY, which is the DPHY. The DPHY is a very unique PHY in the sense that it supports two different modes of operation. One is high speed, which is LVDS type, but it also supports low power operation. As you can imagine, the most important thing for mobile application is the power. So the focus is always about reducing the system power. So the low power operation was included for that reason, which means that you need both a high-speed transmitter, low-power transmitter, high-speed receiver, low-power receiver. This is a half-duplex system, so you have the information flowing both direction, not simultaneously, so you need a contention detector. Then, of course, you have serializer, and you have logic RTL that is needed to enable the system to switch back and forth between the two modes of operation. So we have, as I mentioned, the platform that support this. We provide all the IPs needed, the PHY, the controller, and the platform. The platform consists of a daughter card that integrates the Mixel test chip, and then off-the-shelf FPGA that can incorporate the RTL, our RTL, as well as potentially the customer's RTL if they want to customize it for their particular application. This particular, this is one lane out of many lanes that can be used, that is used for the transmission. So typically you would have one clock lane and multiple data lane. So this is one instantiation, one lane. So the typical PHY would have one clock and multiple data lanes. So because of that, and because the area of the IP, because it has many different transmitters and receiver, of course, it's very important to minimize it. So through the year, we came with different configuration that optimizes for certain applications. Specifically for a receiver, you don't need the transmitter, the high-speed transmitter. So, but you need it if you want to do full-speed loop-back test of the IP, which of course testability is becoming very important. So this particular configuration uses one transmitter with many receiver to be able to do the full-speed loop back without the additional area of the other transmitters. So this results in 35% reduction in area, about 50% reduction in the power dissipation, leakage power dissipation. This is very important for automotive application because, as you can imagine, testability is key for automotive safety testability. Full speed testing is important. You need to do that on a production test. You need to be able to do that in system. So while the chip is in system, to be able to do diagnostic. So this particular IP has been used at different nodes, 55, 40, and 28, and has gone and going into production at a tier 1 automotive semiconductor customer. The other IP, other PHY that MIPI and Mixel support is a CPHY, which is very different as well. So it's not fully differential. It uses a trio, 3 signals. It has clock is embedded into the 3 signals, and it of course uses some coding. We have developed an IP, a combo IP that supports both the DPHY and the CPHY. As I mentioned, the DPHY is very popular. The CPHY is a newer PHY, and this combo enables our customer to transition between the two PHYs very gracefully with very low risk. This is the DPHY section of this IP. Which, as you can see, has a clock lane and multiple data lane. This particular IP operates up to 2.5 gig per second. And it has 4 lanes, which gives you 10 gigabit per second aggregate data rate. It also incorporates desqueuing, which is needed at this higher data rates. This is the CPHY part of the IP. Which, as you can see, each is a trio, 3 signals. So typically you would have 3 trios, which uses 9 signals, while the DPHY has 4 data lanes, 1 clock lane. Each one is differential, so 10 pins. So those pins are used for both applications. And of course, we have designed our IP in such a way that we reuse a lot of the common things to save area and the CPHY provide you with 2.28 bits per symbol, so you can be operating at 2.5 symbol per second and get 17 gigabit per second for the 3 trios, which of course is advantage in to save power and also deal with some media that cannot support the higher transition rate. As you can see, the CPHY diagram is very different than typical LVDS type. This has been silicon proven for about a year now. We have it ready, and multiple customers have used it in their products. This is the third and last MIPI PHY. It's called MPHY. It's more of a traditional embedded clock PHY, so it has full CDR on the receiver side. It uses 1 direction, 2 lines for the transmit, 2 lines for the receive, so it's not duplex that way. And it has, of course, PLL on the top, the transmitters in the middle, the receiver with the CDR on the bottom right-hand corner. On the left-hand corner, you have the encoding, decoding, the state machine that, because many different power down modes, low power operation modes that you need to have a relatively sophisticated RTL to control. This is the daughter card and the test chip for the MPHY. The MPHY operates over many different gears. High-speed gear 1, 2, and 3. High-speed gear 1 operates around 1.5 gigabit per second per lane. High-speed gear 2 is 3 gig. and the high-speed Gear 3 is 6 gig. We provide a full set of deliverables, of course, GDS, data sheet, the LEF, the .lib, the IBIS model, RTL, test benches, integration guidelines. Most importantly, we provide our customers with outstanding support through transfer to production. In conclusion, Mixel has been in business as an IP, mixed signal IP provider since 1998. So we have been involved in MIPI for over 10 years now. Our focus on MIPI enabled us to be the leading provider in that ecosystem. We have the partnership program that help our customer to go to support MIPI and integrate the MIPI and be able to have a MIPI product supporting MIPI very quickly. We have the platform that also helps the customer do that very efficiently with very little effort. We continue to announce multiple first products in terms of support to CPHY, DPHY, new configurations. We provide a very wide coverage of the different nodes and foundries. And we think that because of all of that, we make the best MIPI partner for our customers and potential customers.